Hello, ladies and gentlemen. Good afternoon. And we are covering severe storms tonight, going across the Midwest region and into the Ohio Valley, the lower Great Lakes region. Right now, we're looking at the data viewer for the NATOcast, which is a machine learning program that anticipates severe weather systems. So we are looking at right here in this image right here is the tornado potential for tonight. So if we look at the tornado potential up in the lower Great Lakes in the Ohio Valley, then you can see this increased hatched risk area for some additional risk for large and destructive tornadoes tonight. All right, so we can see that 10% chance in advance of EF2 plus, which is definitely possible. You can see the hatched area there, which is about a 10% additional risk, Blatch hatch, 10% additional risk for any tornadoes within 25 miles of a point. So that's kind of what we're looking at here. You can see the red area of the 15% percentile kind of average for that area being a little bit of a higher accentuation for tornado risk. Alright, so this image here represents our wind. So we're going to have wind shear that's going to be plentiful all over the place throughout every single position in this region. A lot of damaging wind is going to be possible. That wind shear, unfortunately, is going to be supporting a lot of the supercell rotation that's going to be going on in here. It's just going to be very, very easy for storms to move into these areas and be able to rotate very abundantly. Alright, now we can see the hail risk is one of our primary risks throughout most of these storms. You can see these red areas where the additional hail risk is actually coming up here in the NATOcast. And the NATOcast I found is actually pretty accurate when it comes to these systems and anticipating exactly the type of threats that we could see with a lot of these weather systems. But you can see in the Ohio Valley here, these purples that are coming in here, 45%, 60% hail probabilities. This is going to be for damaging hail. You can get some gorilla hail in here, baseball size, maybe even softball size hail, big time, big buku damaging hail. And then, of course, a couple of regions going through the northern Oklahoma into Kansas and Missouri regions where we can see some of that hail as well. And in those regions, actually, we're not even looking at the highest potential tornado risk. In those areas, we're just looking at a lot of severe thunderstorms moving through those areas, bringing with them some damaging wind, definitely hail, because there's a lot of moisture that's going up everywhere. So you can see that going on. This is the convection outlook that the National Weather Service has posted for today, which has been updated several times. And that risk has actually mitigated. It's been mitigated and increased over time here. But you can see these hatched in areas of higher intensity potential for some tornadoes going through this region here. They pretty much just hatched the entire region because some of these tornadoes could be long track. They could be on the larger size, more destructive, very violent winds, and longer track tornadoes. And then you can see the slashed hatched in area here for that additional intensity risk here. We're getting a little bit more intensity in some of those storms, being able to produce some really damaging storms here. Damaging wind risk, primarily we're looking in the south, coming off of the Mexican border and into the central Texas region, where you can see that hatched in area for some damaging winds. And there's a lot of advection that's coming up here through the south, and that advection is just kind of filtering in all of this plume of moisture that's going to be really ramping up these storms and giving them a lot of energy. So that's kind of what we're seeing here. And then, of course, the hail risk. And so you can kind of see how the NATOcast is comparing the hail risk, the wind risk, the tornado risk with the convection outlooks that were posted here throughout the from the National Weather Service. So it is pretty accurate as far as the potential threats for today. All right, so and that's the same thing that we were seeing here on the National Weather Service's site. They've actually updated this to a moderate risk going across the Ohio Valley regions here with that red circle right here, indicating the moderate risk for some tornado potential. Probably here we got a red kind of. This is actually updated since I've last looked at it today. All right, so and then now we actually have a 5% risk throughout this entire region, stretching from Texas all the way up into the Ohio Valley, across Missouri, across Oklahoma, parts of Arkansas, and Kansas. All right, so and even some of the southeastern corner portions of Iowa. All right, so we have a humongous area to cover as far as tornado potential tonight. Ohio Valley being our primary focus because that is where we're seeing the highest risk for that, where you could see some of these storms producing tornadoes, possibly even going through these states with their long tracks, and being able to track northeast through some of these states with those longer tracks. I mean, we have seen tornadoes actually move through states and sometimes hundreds of miles. It doesn't happen often, but it has happened. And, you know, knock on wood, it doesn't happen tonight. All right, so, and then the hail risk has been upgraded, it looks like, down here in the south. But, you know, this whole entire area could see damaging winds, large hail. The damaging wind threat hasn't changed much. They might be updating that pretty soon, though, especially if they're updating and you know, revealing some of these other areas that are going to be more severe. As we get closer to the event, more details kind of come out. All right, so I'm on the high resolution model here. We're going to look at some of the model sample sounding data here to see what's going on. You can see the low pressure systems moving in here, but we're going to go over to the composite reflectivity. All right, there's a lot of areas to cover. I'm going to try to do this as quickly as I can so that it doesn't make this video so long and extended here. But in Texas, we'll start from the south and work our way up. But in Texas here, you're going to see these cells kind of going up really, really quickly. You can see these off to the east. These are kind of prefrontals and are going to be they're going to be serious for a short amount of time. Then you're going to see cells popping off further to the west that are going to actually ramp up and be a little bit more severe. But the hodrographs are looking good with their structure. Storm Slinky's reading the hooking structure that's going to be on it. A lot of damaging wind risk. Lower LCL, which is lifting condensation level. Caps are broken temperatures at 77 and the dew points in the 70s. So tons of moisture that's going to be going on, making the atmosphere just so unstable. So it's making it for a really bad setup for some really severe storms. These cells are actually, I looked at these models earlier this morning, and these cells off to the east are actually looking a little bit more severe than they were this morning. Some of that tornado risk a little bit mitigated and meager at this point, but you can see the notchy kind of features to this line where there's a lot of inflow notches, it looks like, that's in this line. That kind of tells you how the advection is affecting that line of storms. And so in this line of storms, you can have embedded hidden supercells in that line of storms that are rotating in there, so you could have any of those cells in that line dropping tornadoes and you wouldn't see them at all because they're so heavily rain wrapped and covered by a rain curtain there. All right, so a lot of instability with our lapse rates up at 6, our 2400 joules of CAPE here, so a lot of energy that's going to be going on. Helicity levels at 2, our effective inflow at 2.6. So the helicity is the storm energy that's being accumulated in the atmosphere that's really giving these storms the power and the energy to really pack a punch. So you can see that some of these cells, they're going to be packing a really big punch moving through central Texas into the eastern Texas regions, headed toward Arkansas and maybe portions of northern Louisiana as well. These cells off to the west, coming off of the Mexican border into the central Texas region, they're going to go up pretty quickly. And you can see them developing and starting to intensify very, very quickly and very rapidly. And that's going to go through there. You can see these big cells here with these white dots in the center of them right there. That's going to be dropping a lot of hail. All right, so you can see these higher levels of tornado potential in some of these soundings right here, with the supercell the supercell levels up at 18.4, significant tornado parameters from 4 to 5, which is pretty high for STP. And our ship at 2.2, which is our hail, and that's going to be showing you how abundant, really damaging hail is going to be possible here. Surface helicity here at 7.6 to 3 kilometer right here. That's a lot of helicity that's in the atmosphere. There's a lot of energy to go around for these storms to grab at. Our effective inflow at 5.8. So really supportive updrafts here that's going on. A lot of wind shear that's going around. Let's take a look at our upper air dynamics right here and take a look at maybe 700. Actually, you know what? Let's go to this one. 500 millibar height wind. So you can see the wind shear that's moving into this area here, 70 knots, wind shear somewhere around there at 500 millibar, which is pretty substantial. All right, then you got the westerlies that are going to be moving in here. This is what's causing a lot of that rotation and a lot of that spin in the atmosphere. Being able to have those westerlies mix in and mesh with those southerly winds, causing a lot of that supercell development, that spin in the atmosphere. All right, so going back to composite reflectivity now. All right, so you can see how these storms converge, and you can see these little dots in here where there is a bunch of isolated cells. Let me zoom in on this a little bit. So you can see these little dots in here, these little purple dots that are going up this line of storms. These are isolated embedded supercells that are hidden in that line of storms, where any one of these, you could have 2 or 3 of these actually producing tornadoes actively, especially with this big huge bowing feature that's kind of coming around that storm right there. Those bowing features often bring a lot of really heavy winds even aloft of them and ahead of them, especially when you don't have a whole lot of bluing out like you do in this section, not a whole lot of rain out there. You're going to get it all at once, and there's going to be some probably straight line damaging winds ahead of that line as they come up there. So this is kind of a day where you don't really need to have tornadoes in order to have possible wind damage. All right, so that continues, and these cells also being able to have the potential for some damaging tornadoes, big tornadoes, possibly long track like this sounding here. This is that big cell off to the south right here. Really, really organized wind field that's on the south right there, on the bottom of this towards the surface right here. All right, so really, really strong wind field, really strong updraft and downdraft right here. RFD is, the hydrograph is showing a really, really nice structure with that forward flanking downdraft facing off to the northeast. So that big kind of hooking structure right there just kind of tells you, you're going to have a lot of things wrapping. Being able to see these storms form, that anatomy. You can see this big cell right here. That's the cell that we were just looking at the sounding for. Really big white dot in the middle of it, being able to drop some of that gorilla hail. You're probably going to see some of those greenish skies in Texas, going into the later portions of the afternoon. Right now, we are looking at 8 p.m. That's when, about 7 o'clock, 6 to 7 o'clock is when we're assuming that these cells are really going to start to ramp up and organize and really start to get severe on that end. And then the rest of this is unfortunately going to be a nocturnal event. These storms are going to be heavily rain-wrapped. They're going to be showing up in the darkness hours of the evening. This is not a night that you want to be out there with your phone trying to take videos of these storms. You're not going to see them. You will be able to hear them, but you won't be able to see them. They're going to be heavily rain-wrapped, and they're going to be under the cover of darkness. So this is one of those things where, honestly, on a day like this, if you get a severe thunderstorm warning, please get to your safe place and get in your shelter immediately, because they can go tornado warned on a day like this within seconds to a couple of minutes. And by that time you could literally have only 2 or 3 minutes to get to a substantial shelter. So this is definitely a day to just hunker down, be near a shelter or somewhere close to one where you can get safe quickly. All right, because these storms are going up really rapidly, really quickly. There's a lot of this going on where you see these big cells actually dissipating, and they're actually being absorbed. Their energy is being suffocated and absorbed into the main line of storms, where you can see all these dots that's going up here. These are all embedded, isolated cells that are ramping up really quickly, taking energy and helicity from the other storms around them. Now, this is early on, off to the southwest of that line. These cells are coming across the border. They're ramping up very, very rapidly. So this is actually before that organization starts to really happen off to the southwest. And we give it an hour, and we just start to see a much larger picture of that. All right, this top portion of the line right here, already severe, possibly already dropping tornadoes at this point. You see this big, huge hooking structure on that storm slinky, and the hydrograph right there with that big, huge hooking segment right there, these critical angles, that FFD off to the northeast here. This kind of structure, it just kind of tells me it's going to be really supportive of right moving cells and a lot of spin and a lot of rotation, that organization being able to drop some really substantial tornadoes. All right, so now an hour later, we were looking at this cell just an hour before. We're looking at the about 10 o'clock in the evening right here. Let's take a look now at that point. Still a little bit stumbling on the organization off to the southwest. All right, so that also could be because some of these other cells off to the north are still kind of pulling some of that energy up. I think it's a little bit close, too close to the border, but I do know that at this time, this is where the CAPE, if I go to surface-based CAPE here, all right, but I do know that in the last few hours of the evening, going up towards the midnight, you can see I was going back in the models here. Excuse me, the CAPE is actually pretty severe early on when we see those cells actually becoming severe in Texas, in central Texas. Then you can see the CAPE kind of dissipating and starting to disappear out here as a cold front moves upon and then, you know, pushes out a lot of the instability. But the other side of this, look where the instability is going. So the instability in Texas is actually dissipating and going out. The rest of it is moving and shooting straight for the northeast. All right, so you see that all moving into the northeast. We're talking about Arkansas, we're talking about Missouri, parts of Oklahoma and Kansas, is still having some of that richly potential CAPE and energy there. All right, some of that is going to be favorable for those storms moving into that area to become severe. All right, so I'm going to actually bump this up just a little bit so that we can see the storms a little bit further north. Okay, and so we're looking at Arkansas, Oklahoma. Here's Missouri right here. So you can see these storms here in Missouri, some isolated cells actually moving through Oklahoma and Kansas. Some of these being able to have some potential, at least some potential, to drop some possible tornadoes. It's a little bit on the lower risk kind of scale just because we got a little bit of disorganization that's going on in there. But the wind field is stable and we have plenty of wind shear in this area. You can see the 69 to 110 knots of wind shear possible that's going to be feeding these storms. Supercell development is very, very high. Some of the SIGTOR is inconsistent, but I still think that there's enough for some of these cells moving through these regions of Oklahoma and Kansas and then into Missouri, where you can have some potential tornadoes all throughout this region. Look here in Missouri, going into the Missouri region, that line of storms off to the southwest end of it, featuring a lot of helicity, a lot of supercell development. SIGTOR is way up there. Instability is way up there. Those regions, this is, let me see here, 7, 8, 9, 10, 11. We're looking at the 11 o'clock to 12 o'clock region of going into the evening and night hours of midnight and on. That line of storms moving out of Kansas into, it's into eastern Kansas and then moving into the border region here of Missouri. All right, so an hour later, we're looking at about midnight now. And you can see these isolated cells really, really super notchy in that line of storms. You can see how all these little kind of cells embedded in that line right there having a lot of inflow notches that are going on in there. So that just kind of shows you how hard that advection is that's moving through there. All right, so and then they start to die down a little bit, and I think that's just because of some of the CAPE that's being choked off here as it's moving and shooting off to the northeast. Some of that, the cold front is going to be moving through. We still have some cells higher up in that line here, still potential of some really big tornado possibility. All right, a lot of helicity that's in the atmosphere right here. Lapse rates up in the 7s, in the 7 range. A lot of instability, 2,300 joules most unstable CAPE. So big time shear and big time instability equals big time possible tornadoes. All right, so now we're going to get into the region further up to the north here, where we're looking at the possibility for some big tornadoes moving across the Ohio Valley. I'm actually going to back this model guidance up, or I'm going to back it up we're going to go into the later portions of the afternoon right here. All right, so we are looking at, the later afternoon hours. You can start to see these cells really starting to come into the Illinois region. already potential for some tornado development even early on. This is what I'm talking about. These cells, they actually build and they start to organize really quickly, a lot faster than what we anticipated originally. And that's why I think that these convection outlooks were upgraded again and again and again very quickly, is because they didn't realize, we never even realized. I looked at these a couple of days ago, all these models, and they jumped up in severity and how quickly the storms were going up quite a bit. So I mean, I've been tracking this for a while, but it didn't look like this. So these cells being able to drop some really substantial tornadoes, because even in what happened with Michigan, that tornado that happened in Michigan, it didn't have a sounding that looked like this. It looked like a lower end tornado threat. It didn't look as potential. I mean, it didn't even have helicity levels this high in the sounding data. So when it spun out, that tornado that happened in Michigan did as much damage as it did, it was a little surprising, to be honest with you, with the model guidance that we had for it. We didn't anticipate that it was going to be that bad. But now across the Ohio Valley, we're getting soundings like this that look pretty ugly as far as how bad and how possibly severe this storm really could be, and how dangerous it could be. We're looking at temperatures of 74, dew points of 64 degrees, SHIP is at 2.1, which is going to be indicative of your hail. All right, so and you can see the significant hail in the analogs right here. Really damaging hail, and a lot of it is what we're looking at. The wind field is completely stable. There's not a whole lot of instabilities or anything like that. Got a little bit of veering winds in here, but that just supports a lot of the rate moving cells. It supports the updrafts and the inflow into these storms, as well as an organized RFD, which is the rear flanking downdraft. So all the accoutrement essentially is coming together for these storms to really ramp out and become very severe. Going across Indiana, these storms actually intensify, going further east into the northern Indiana region, and you can see these hydrographs are pretty much textbook for a tornado setup. Slinky's reading that hard hook there as well. Instability, very high, 2,500 joules of CAPE. Lapse rates all up to 7 STP is our significant tornado parameter. The CIN is usually what I trust a little bit more, because I feel that it's a little bit more accurate than the fix. However, when these two are not too far apart and they're pretty close in consistency, that definitely tells me that this is an accurate sounding of how consistent this reading is how, of how bad and how severe this storm possibly could be. With a lot of supercell development up at 12.5, we're looking at 2.7 on the shift, so a lot of big fat hail being able to come down and do some significant damage and even cause injury if you get hit with it. So please, if you see hail, get under some cover or get to a shelter of some kind to not be out in that, because it can cause injuries or even death sometimes if it's large enough. It's very dangerous, very dangerous situation. Now you can see about an hour later, we're looking at 7 p.m. now in the Ohio Valley. You can see how those widespread cells just kind of blow up, and they're covering such a broad area now. So any of these isolated cells that are kind of embedding themselves in what looks to be a converging line of storms, and they embed themselves in there, you could have little isolated tornadoes in there already starting to form. What you're going to have is these storms grabbing energy from each other, but they have the potential to make for even 1 or 2 or 3 or a couple of these big buku storms being able to drop very damaging tornadoes, very long track destructive tornadoes, very dangerous storms. All right, especially with our SIGTORs up as high as they are, with the supercell development being really rampant. All right, and our SHIP up there with the significant dropping hail, damaging hail that's going on. Look at our EHI levels right here, which is our helicity, up in the 4 range to 5 range. I mean, that's some of the highest helicity levels that I've ever seen, and I've been doing this for 16 years. So some of the highest indications of tornado threat and severe weather threat that I've seen in all of my years of doing this. I'm actually going to go to a further north region right here because I also want to see what's going on in the lower Great Lakes up here. Not really a whole lot of tornado potential being expected up into this far of these regions, but the reason I want to cover this is because up this far north there's also supposed to be a big wave of cold that's going through there. These storms up here are actually causing dendritic growth zones, which is the area of the atmosphere which snow and ice is made. So some of the storms that I was looking at earlier going across Wisconsin, possibly up into Michigan, there's a lot of freezing rain. You can see the rain here on the OPRH at minus 16 here. All right, so a lot of this, you can see these yellow lines right here. This is the dendritic growth zone, and that's where the snow and ice is made in the atmosphere. So right there, some of this rain that's coming down could be freezing rain and a little bit icy. So if you're out on the roads and everything like that, please be careful. Could get some slippery conditions. All right, so moving further west, looking at some of these cells further to the west that are coming in across from Iowa. Also, being able to actually form tornadoes in in eastern Iowa, being able to move into western Illinois. Some of those long track tornadoes moving into Illinois, and especially over parts of Illinois that have already been hit by the storms further to the east. So you could see areas getting hit more than once. All right, so that's kind of another issue here. You can see these storms off to the south on this further eastern portion, a lot of notching that's going on here. You can actually see a little bit of a hook feature in some of these as well. So these are the kind of storms that I'm talking about where they got that kind of structure. They look like they could already be in this model. They already could have tornadoes on the ground in this model at this time, moving across these regions. All right, so and this is we're looking at 8 p.m. So this is all going to be happening into the evening hours. Most of these are going to be nocturnal events, unfortunately. If we look at the surface-based cape here. All right, so you can see the cape off to the south here. This is moving up with the advection. It's being able to fuel these storms to keep them going. You know what I mean? So it's going to be able to keep them going until that cape ends up kind of bleeding off a little bit, being able to choke these storms out. The SIGTOR, all right, so this is the significant tornado parameters, and you can see these high levels of significant tornado parameters. In most cases, you only need a SIGTOR of 1.0 to really have these storms become severe. Anything over the 1.0 range, you're getting a high level of SIGTOR. So this just kind of shows you in that example here where we're getting 2s, we're getting 3s, we're getting 4s in some regions. That's a lot of significant tornado parameter that's in these areas. Supercell composite is probably going to be about the same, where you're looking at those high levels of significant tornado parameter coming up with the advection with a lot of that heat, a lot of that moisture, and definitely southern wind shear. All right, so if we look at 500 millibar height wind right here, we're looking at a lot of these hard westerly winds coming in here, 50, 60 knots, somewhere around there. 700 millibar, let's look at 850 actually, 850 height wind right there. You can see some of that that's coming up here with a lot of that heat. That's part of that southern advection. Moving around the low pressure system, which is going to be off further to the west. Further to the west, going towards Nebraska, Iowa region right there. As the low's coming up, it's going to be bringing those southerly winds, mixing with those westerlies that are going to be coming in through there. If we look at some of our dew points right here, let's look at what our dew points are doing. So you can see that big, huge plume of moisture that's moving up there. Low pressure system, like I said, off to the west, all right, where the winds are kind of curling around it. You get that southern advection coming in here with a lot of heat and a lot of moisture. You can see the heat right here, temperatures in the 70s, whole lot of heat. There's just so much instability in this atmosphere right now that it just leaves a massive potential for some very, very extreme storms that are potentially extremely dangerous. All right, so as we continue on throughout the evening, now we're looking at 9 o'clock, 9 p.m., you can see down in Missouri, some of those storms being able to move through northern Missouri already at that point being able to drop substantial tornadoes. Look at this reading right here, this sounding right here. Very, very high levels of tornado risk moving across northern Missouri. And that's a big problem because, again, you could see tornadoes forming in northern Missouri region, and some of those, like I said earlier, could be larger in size, more destructive with violent winds and long track. Now you have these tornadoes moving into these northeastern regions of mid to upper Illinois, even parts possibly of Indiana, in areas that have already been hit by severe storms. So you can see other areas being hit more than once possibly, depending on what happens here with the instability and the way these storms develop. You can see the whole thing actually merging and converging into a big, huge squall line pretty much of storms. Alright, so a lot of these are showing embedded cells. You see these little dotty, kind of spotty segments to these storm lines right here. These are all embedded cells that are in that line. Even further off to the east here, going through northern Indiana, these northern Indiana regions still being able to to have that potential for supportive tornado development. All right, and then across northern Illinois, some of those cells moving in, going over those areas that have already been hit. Now we got storms moving out of Kansas and into Missouri, across the Missouri line, which when we get over there, we already have wet and moist conditions in the Midwest, like Kansas, Oklahoma. But now when they move into Missouri, then you're talking about more buoyant moisture and more unstable atmosphere because of the heat and the moisture that is absorbed into Missouri. These storms moving in, having the potential for massive tornado development, still continuing on through Missouri. So let's track this through 11. Now we're looking at midnight. Alright, so around the midnight range, you still have storms off to the east moving through northern Indiana, where we still have some of that mitigated tornado risk. It's actually coming down in severity. It's starting to at this point now, those storms off to the east anyways are starting to come down in intensity, and they're starting to die down a little bit, but they're still severe enough to have at least some damaging and destructive severe thunderstorms. We do still have, off to the southwest of that line, we do still have some massive tornado potential with some particularly dangerous situation, tornado possible hazard types here. So which is going to be, look at our helicity levels up at 3. Still a very, very dangerous storm. You know, big, huge, wide hooking segment on the hydrograph right here. I mean, I hate to say this, but a lot of times we see this with setups that have produced wedge tornadoes. You know what I mean? And I hope and pray that that's not the case here tonight, that we're not going to be seeing anything like a wedge tornado. But I can't sit here and say that it isn't possible with setups like this, with this kind of indications. You could see extremely large damaging tornadoes out of this. You know, and I mean, I hate to be the one to say that. And, you know, back here further off to the west in Illinois, still looking like really, really big potential for some very large damaging tornadoes. This is, I don't usually use this word very often, but this is the kind of setup that could be potential for a complete tornado outbreak in one night. I mean, because this storm has so many instabilities and so many different cells that are tornadic. You could have multiple tornadoes on the ground moving through these regions. I don't use the word outbreak too often just because I don't want to you know, over exaggerate the situation. I want to give you the most accurate information that I can, but this definitely looks like it could be potential for an outbreak situation of multiple tornadoes going through these areas, at least for a short amount of time where you have these multiple tornadoes here. Now it does seem like there is some destabilization that's going on at this point. Okay, so now we can see the cape is starting to die off. It's starting to come down a little bit in intensity. So that cape is not feeding these storms as abundantly. We've still got damaging wind shear. We still got some really heavy torrential rainfall in this area. We still have some damaging hail potential. and some likely severe thunderstorms that are going to be going on with cloud to ground lightning is possible, with some of that might be positively charged. So power outages are likely, could have some transformers blowing, and definitely don't be outside. If you see lightning, get under cover, because some of that lightning could really mess you up if it hits near you even. We're talking about some big boy lightning. All right, so going across these areas, it does seem like there is some destabilization going into the early morning hours of tomorrow morning. Still some of that tornado risk that is kind of lingering. However, the helicity levels look like they're coming down. All right, so some of that could be contributing factors to some of the destabilization of some of these storms. Some of these are looking like there's still potential of dropping tornadoes. So that instability, it hangs around for a while. It's going to sit there. It's going to actually be able to fuel these storms for a little bit longer. This is going up into 1 o'clock in the morning. All right, so 1 in the morning, 2 in the morning, we're still seeing some embedded cells still kind of trying to survive and hang on there with a lot of their intensity. You can see the helicity levels in this sounding right here at 3. Still being able to hang on to some of that tornado potential going across northern Indiana. These storms off further to the south, the one thing that I'm noticing with these are these big bowing segments, not a whole lot of bluing that's out in front of this line right here. So that means as these storms move up to your area, if you are in these areas right here, you can have some abundant straight line winds that are damaging winds as this comes up. They'll last for a little while, just a few minutes, until that line passes your area, and then eventually it'll die down. But some of that initial wind shear that's coming up with this line right here, it could do some serious damage sometimes. Take some shingles off, take some of your siding off of your home, possibly even throw some items around the yard that might actually turn into projectiles and debris that can break some windows or even cause some injuries. So definitely be mindful of that. But let's take a look right in here. Still some of that lower end tornado threat hanging around. We still have a little bit of helicity that's moving in the atmosphere here at the 2-point range. So a little bit of energy that's still kind of charged in the atmosphere here to be able to really give these storms a little bit of that potential severity. Now you can see that converging that's going on with that further northeastern line of storms, still trying to hang on there. A little bit of a power battle as these storms are trying to grab at whatever energy that they can, because right now the Cape is receding and it's starting to starve these storms of that energy, so they're starting to die off a little bit. But as I said earlier, that sharp line right here that's coming up to the area, you get a little bit of that bowing segment, those sharp aggressive lines right there, starting to be able to move into those areas and bring some straight line winds and possibly some damaging winds with them. If we look let's look just to the southeast, ahead of that line, you can still see that tornado potential a lot lower than it was before. However, definitely not zero. Still potential to have some embedded tornadoes in that line of storms. All right, so definitely keep those devices on. Keep them ready for warnings throughout the evening. If you decide to go to bed in these areas and everything, make sure you keep your devices on, charged, and powered to be able to get warnings, because severe thunderstorm warnings and tornado warnings could be within seconds or minutes. All right. And then going into these early morning hours, you see these isolated cells just all over the place. All right, some of these isolated cells could be also producing little spin-up and brief spin-up and isolated tornadoes throughout the early morning hours as this storm is being choked off and starting to die down a little bit. So all of these areas, even up into Michigan, where we're seeing some of these severe thunderstorms, you still could see some wind bands up there that are damaging, and especially with the cooler temperatures and the kind of winter storm kind of thing that we're going to get here in the Great Lakes. I live in upstate New York, so later this week we even have some winter storms that are coming up to us as well as a product of this storm specifically. All right, so these isolated storms moving into these areas, still having the potential possibly to drop some damaging tornadoes at this point. All right, with that weakening, some of those tornadoes might be short-lived. They might be isolated. Hopefully that's the case, where they just kind of hit some rural areas and not very highly populated areas, and then they just kind of die off. But through this storm tonight, you could see at least one or two very large and destructive long track tornadoes out of this storm, if not more. So that was my thing. Sorry. All right, so that kind of covers from the south to the north as far as the storms continuing on tomorrow. They don't look nearly as severe. There is still that potential for some tornado risk tomorrow, but it's a lot lower on the scale. So we're going to kind of look at those aftershocks of this storm as it continues off to the east. I'll do another forecast when we get a little bit more information closer to the event tomorrow. All right, so definitely gonna keep my eye open on that. Yeah, this is not a day to take warnings and watches lightly. I just hope everybody stays safe out there. Thank you very much for watching me, and feel free to leave comments. And if you're on my Facebook page, go ahead and email me your questions or anything like that. I'll do anything I can to help you out. So stay safe. Have a great day. And I hope everybody sees another day tomorrow successfully. I hope it isn't that bad. Alrighty. Thanks again.